Hi, this is Dayway. Welcome to today's KYMC YouTube video. Communication has enabled the society to advance. As human beings, we communicate effectively and efficiently through different methods, such as text, in sound and code, or in pictures. And we communicate differently using different languages: English, Chinese, Spanish, French, Malaysian, you name it. And as a printing professional, how do we communicate in color? What is the common color language to enable us to be on the same page? This is what we'll be covering today in today's video. To begin with, we first need to identify what is color. Color is defined as the perception of light that has been modified by object. There are three main elements when it comes to identifying what color is, which are light source, object, and the perceived human eye or the perceived instrument. Light can be broken down into different categories by its wavelengths and frequency. For instance, X-rays, ultraviolet rays, infrared radiation, heat, radio waves. And the human eye can perceive light within a certain wavelength, and we call this range of wavelength the visible spectrum. The visible spectrum has different wavelengths of different light intensity. When a light is shown onto the object will absorb certain wavelength and reflect others. The reflected wavelengths will be perceived by the human eye or instrument as a certain color. So for instance, a green leaf appears green because the object green leaf has absorbed the wavelengths of red and blue and reflected green. Therefore, we perceive the leaf as green. Okay? The human color vision is broken down into three primary colors: red, green, and blue. The eye has centers or receptors that will detect these three primary colors, and all the colors that we perceive are a mixture of these primary colors. Different light sources will have different intensity of the red, green, and blue. Therefore, people will perceive light differently under different light source. Therefore, when we communicate in color, the first step is to have a controlled light source. We need a consistent light source to evaluate what the color is. That is the first step. Okay, so now we have a consistent light source. The human eye still perceive light differently. Why? Because the human eye has three sensors or receptors that detect the three primary colors. These receptors are called cones, and different people's cones has different sensitivity to the different wavelengths. To provide a more extreme example, for the people that are colorblind people, they are unable to perceive light at certain wavelengths. Therefore, even under the same light source, us humans are biased by nature when evaluating color. To overcome this, we need a mathematical model to quantify the color. So in today's industry, two common mathematical models are used, which are the LAB model and the LCH model. The LAB model, in L, stands for the lightness. It is the vertical dimension in the color space. And A and B is the X and Y coordinates of the chromatic plane. And for the LCH model, instead of using the X and Y coordinates, it uses a polar coordinate to locate the color in the color space. And now we have a mathematical model to identify the color. During practice, production, printing, we will always have an actual value and a target LAB or LCH value. So how do we know how far are we off? How do we know how far are we off from the actual to the target? To do that, we calculate something what is called the delta E value. Delta E value. Delta E value is not that simple. The same delta E value in the color space will be perceived differently by the human eye. For instance, the same delta E value in neutral gray will be more apparent than in the saturated dark red. And to overcome this, there are different weighting calculations that are implemented to the delta E equation. Some of the common weighting methods include the CMC, CIE 94, CIE 2000. Okay, that's it for today's video. And to summarize, today we have covered what is color. And color will be perceived differently under different light source and will be perceived differently by different human beings. And to overcome this bias, we need a mathematical model to quantify color, which is the LAB model or the LCH model. And during practice, during production, we will always have an actual and a target. And to measure how far is the actual from the target, we calculate something called the delta E. And that's it for today's video. And thank you for watching, and we'll see you next time.